Hello and welcome to another week of PowerMaths. Now we've finished our time topic and we're moving on to a new topic today. We're going to be looking at measuring, but we're not going to be looking at measuring the length and the width of things like we have done before. In this topic, we're going to be looking at measuring how much something weighs, so its mass. We're going to be looking at measuring the temperature of things, and we're also going to be looking at measuring how big something is, its volume or its capacity. This is a really great topic because it's one of those topics that's really useful for real life. We do this sort of stuff all the time in real life. But let's get going with our Flashback 4 to get started, and then we'll move into our first lesson. Here's today's Flashback 4 then. Have a go, click pause here, and click play when you're ready to go through the answers. Let's have a look at question 1 then. Question 1, how long did the program last? So you need to be looking at the minute hand here and working out the difference between the start and the end time, and it was 20 minutes. We can count round in fives, 5, 10, 15, 20, and it's now pointing at the 4, 20 past 10. Okay, question 2, what time is shown on the clock? It was 25 past 9. Question 3, use the less than, greater than, or equal to sign to compare the lengths. 30 centimetres is less than or smaller than 3 metres. And lastly, what is 3/4 of 12? The answer is 9. All right, let's have a look at today's lesson. Okay, before we get going with our Discover today, I just want to remind you about these 3 mathematical symbols. They're really, really important and we're going to need them in this topic. So we've got over here our equal symbol, which we use all the time in maths, and it means same as. Whatever is on this side of the symbol is the same as whatever's on this side of the symbol. Then we've got our greater than and our less than symbols. And an easy way to remember which way round these go is by looking at what they start with. If they start with the big open bit, then they are greater than. And if they start with the smaller bit, then they are less than or smaller than. Okay, so just make sure that you know these 3 symbols. If you need to come back to this part in the video and check at any point what these symbols mean, then go for it because it's really important that you're confident with these. Let's have a look at today's Discover then. Okay, so we've got a family here going on a camping trip. And you can see that they've got a tent, some sleeping bags, and some food. And Mum's saying, I will carry the heaviest. And Big Sister is saying to the little brother, you should carry the lightest. In question 1a, you are asked, how can you find out what each person should carry? Now, you don't need to work this out exactly. You just need to think about how could you find out what each person should carry? How are you going to work that out? In part B, you are asked, one sleeping bag has the same mass. For now, think about that as weight. One sleeping bag has the same mass as 2 bottles. What is the mass of 3 sleeping bags in bottles? So have a think about that. Think about how you could work this out, what representations you could perhaps use to help you. So click pause here, have a think about those questions, and click play when you want to talk about the Walt and Wilfs and share the answers. Great, let's have a look at today's Walt and Wilfs. So our Walt is to compare different masses. Our Wilfs are to use the word heavier and lighter, and to use the greater than, less than, and equals symbols, and finally to compare different masses. Okay, we keep talking about this word mass, so let's talk about what it actually means. Mass means how much stuff is in something. It's very similar to the idea of weight, how much something weighs. But it's very different from size. So think about this. You could have something that was very big, but it didn't weigh very much. And we would call that something with a small mass. And you could have something that was very small, but it weighed a lot. It was super, super heavy, and that would have a big mass. So think about mass in terms of weight, how heavy something is or how light something is. All right, let's have a look at these questions then. So in part A, we were asked, how can you find out what each person should carry? Let's have a look and see. So Spark says you should use a balance to be exact when comparing mass. We need to find a way of working out what's heavier. And look, we're using what's basically like some weighing scales. We can see by putting a plank over this rock which side is heavier. And if you had gone and done this and you had these things in real life, you would have worked out that the tent was heavier than the sleeping bags because look, it pushed this side of the balance to the ground. You'd have worked out that the red bag was lighter than the tent. And then if you'd compared the red bag and the sleeping bags, you would have seen that the red bag was heavier. So from this, you could have worked out, well, mum needs to carry the heaviest thing, which is the purple tent. Sister can carry the red bag because this is heavier than the sleeping bags, and little brother can carry the sleeping bags. Let's have a look at part B then, because this is where you are asked to work out what the mass of 3 sleeping bags was in bottles. And you need to think about what things you could compare to do this. Now, down here, we've got, again, some balances. So we know, because we were told, that 1 sleeping bag has the same mass, so weighs the same, as 2 bottles. So look here, the balance is perfectly balanced. Now, if we were to add 2 more sleeping bags, well, to match it, we would need to add 2 bottles for every sleeping bag. So have a look, we've added 1 more sleeping bag and 1 more pair of bottles, and then another sleeping bag and another pair of bottles. So altogether, these 3 sleeping bags have got 1, 2, 3, 4, 5, 6, or we could count that in 2s, 2, 4, 6 bottles to make this balanced. So 3 sleeping bags have the same mass as 3 lots of 2 bottles, which is 6 bottles. The other way you could have done this would be by doing a bar model. If you know that 1 sleeping bag has 2 bottles, then you could have drawn those bars out and then worked out how many bottles you'd need for 3. Right, let's have a think together. So question 1 today says this, complete the sentences. So we've got gaps that we need to fill in, and we've got heavier than, and then we've got to find out which is the heaviest and which is the lightest. So let's have a look at this one here. Of the 2 things, the hammer and the torch, look at the balance, which is heavier? Yeah, that's right, the hammer is heavier. So we can say that the hammer is heavier than the torch. Right, let's have a look over here. We've got another balance and we've got the tent and the hammer. Which is heavier? Yeah, that's right, the tent is heavier because you can see that this side of the balance is touching down to the ground. So the tent is heavier than the hammer. Okay, so which is the heaviest then? Well, we need to look at both together now. Just looking at the first one, we know that the hammer was the heaviest. But is the hammer the heaviest overall? Well, when we put the hammer up against the tent, we find out that the tent is even heavier than the hammer. So the tent must be the heaviest. Now, what about the lightest? Well, in the first one, the torch was the lightest. And we know that the torch is even lighter than the hammer. So even though the hammer is lighter than the tent, the torch is the lightest overall. So the tent is the heaviest and the torch is the lightest. Right, now we're comparing masses again, just like we did before. So let's have a read. So this is a camping stove. So this is something that you would use to cook your food on. So it looks a little bit unusual, but that's what it is. So the camping stove has the same mass as 10 bottles. And there it is, we can see that. Look, camping stove, 10 bottles, perfectly balanced. Write the mass of the other items in bottles. So have a look at these other ones, and your job is to try and work out how much each of these weighs in bottles. So how much the hammer weighs in bottles and how much the tent weighs in bottles. Things to think about. I want you to have a go at this. What does the balance beam show you? And could you draw another representation to help you? Think back to the discover and the share. I suggested perhaps you could draw bar models to help you. Have a go at that because I think that will make this a lot easier for you. So have a go at question 2, give it your best shot, click pause here and then click play when you want to see the answers. Right, let's talk about this question then. So the first thing we're being asked to work out is the mass of the hammer in bottles. So I've made them a bit bigger over here, those first 2 balance beams. So the first balance beam shows us that the camping stove is the same as or is equal to 10 bottles. So the camping stove equals 10 bottles. Right, let's have a look over here. Now we're comparing the camping stove and we've got 2 bottles and a hammer. But notice it's completely balanced still. So in this one we find out that the camping stove is the same as 10 bottles. So have a look at this picture I've added in above. Normally we know that the camping stove is the same as 10 bottles. But here we've got 2 bottles and a hammer. So if we look, the hammer must be the same as these extra 8 bottles. Because if we were just using bottles, we would have 10 altogether, and we've only got 2. And 2 and 8 would make 10 altogether. So this hammer must be the same as those leftover 8 bottles that we haven't included. So we can say that the hammer is the same as 8 bottles. Right, now let's have a look at this last balance beam. You can see that we've got 2 hammers is the same as a tent. So how are we going to work out what the tent is? Well, we just need to do 2 lots of the hammer. And we know that the hammer is 8 bottles, so 2 lots of that is 16 bottles. So the tent is the same as 16 bottles. Again, you could have shown this on a bar model. Bar models are really helpful for comparing different things. And in the next question, we're going to see that really clearly. So the challenge. Another family go camping. Molly says, my bag is twice as heavy as a tent. Jack says, my bag is half as heavy as Molly's. And Dad says, my bag is 5 times as heavy as Molly's. Part A, whose bag is the heaviest? And part B, whose bag is the lightest? And here we've got Ash who's giving us an idea. I wonder how many tents balance each bag. Now, normally I would get you to have a go at this, and you can click pause here and get straight into this and have a go. But if you want, you can keep watching, and I'm going to show you how you can use bar models to answer a question like this. Now, there's a lot of information in this question, and there's a lot of steps. And that's why it's a challenge question. But using bar models, we can work through this really easily. Let's have a look at this first bit. Molly says, my bag is twice as heavy as a tent. So let's look how we could draw this. Here's Molly's bag, and we know that it's 2 times as heavy as a tent. It's twice as heavy. So you can see in my bar, Molly's bag is the same as 2 tents. Right, let's look next. Jack says my bag is half as heavy as Molly's. Well, this is easy. We can draw this out again. Here's Molly's bag and here's Jack's bag. And you can see straight away just by looking at it, Jack's bag is half as heavy as Molly's. So at the moment, Molly's bag is the heaviest and Jack's is the lightest. But we need to think about Dad's bag, don't we? Dad says that his bag is 5 times as heavy as Molly's. Right, this is going to be a big one to draw out. Have a look at this. We've got 5 lots of Molly's bag just to make up 1 of Dad's bag. So looking at these, we now know that Dad's bag is definitely the heaviest. And whose bag is the lightest? Well, it's not Molly's bag because Molly's bag is bigger than Jack's bag. It must be Jack's bag. His is the lightest bag. So now all of that information, we've worked it through step by step, drawing out some bar models, and we've worked out that Dad's bag is the heaviest, and Jack's bag is the lightest. Remember, we're not talking about size. Even though we've represented it here as bags that weigh more are bigger, we're still talking about how much they weigh, not how big they are. But bar models are a really helpful way to approach questions, comparing things so that you can see really easily. Okay, well done with these. Time for you to have a go in your practice book. So you're on page 87 today, and again, join me for an extension question afterwards. So click pause here, have a go, and I'll see you in a bit. Well done on having a go in your practice book. Let's do those extension questions. Your extension question today. True or false? 4 bananas weighs more than 2 pineapples. True or false? Click pause and click play when you have your answer. Ready? It's false. If you have a look, the scales are balanced, so 4 bananas must weigh the same as 2 pineapples. Look, there they are balanced, so really we need an equals sign. 4 bananas is equal to 2 pineapples. Okay, well done today. We'll finish things there. Well done on finishing your first lesson in this topic. I look forward to the next one. I'll see you again soon.